Students, welcome to the class. Today's class we are going to discuss about the topic antenna and wave propagation in that antenna arrays topic presented by Mainaka Devi, Assistant Professor, Department of Electronics and Communication Engineering. So these are all the outlines of today's class. What is an antenna array? Array of 2-point sources, types of array elements, basic principles of antenna array. So first of all, what is an antenna array? An antenna array is a group of antennas connected and arranged in a regular structure to form a single antenna that is able to produce radiation patterns not produced by individual antennas. In simple words, array is nothing but a collection of similar elements. It means that antenna array is collection of similar antennas are arranged together. So that this is antenna array. So antenna arrays are group of isotropic radiators or electromagnetic frequency and energy. So they provide a solution to the problems caused by single antennas. Types of array antennas: broadside array, end-fire array, collinear array. So first type is broadside array. A broadside array is a one or two-dimensional array in which the direction of radiation, nothing but main lobe of the radiated waves, is perpendicular to the plane of the antenna. So physically it looks somewhat like a ladder. When the array and the elements in it are polarized horizontally, it looks like an upright ladder. When the array is polarized vertically, it looks like a ladder lying one side. So compared with collinear arrays, broadside array tune sharply but loss efficiency so rapidly when not operated on the frequencies for which they are designed. So this is the arrangement of broadside array. This is the antenna array axis. Here are the filament antenna 1, 2, 3, 4 and 5. So these antenna elements are similar to each other. These antenna elements are arranged. It's vertical to the array axis. So maximum radiation in the vertical direction. So in the second one is in this image, we can able to see the radiation pattern of broadside array. So the main beam or major lobe in the y-axis and the minor lobes or side lobes are in the x-axis. So this is the radiation pattern of broadside array. So the next antenna array type is end fire array. So the end fire array is similar to broadside array, only the radiation pattern is different. So an end fire is a linear array in which the direction of radiation is along the line of the antennas. The antennas must be fed with a phase difference equal to the separation of adjacent antennas. In the context of antennas, end-fire coupling is often associated with the directional antennas, where the main radiator lobe is directed along the axis of the antenna. This configuration allows for a one more focused and directive radiation pattern in a specific direction. So this is the field pattern or radiation pattern of broadside array. Here the antenna elements are arranged parallel to the array axis. So the radiation pattern is in the x-axis. So the minor lobes are in the other directions. And the third antenna array category is collinear array. The purpose of stacking multiple antennas in a vertical collinear array is to increase the power radiated in a horizontal direction and reduce the power radiated into the sky or down toward the earth where it is wasted. So a collinear array consists of two or more half-wave dipoles which are placed end to end. These antennas are placed on a common line or axis, being parallel or collinear. Collinear arrays are high gain omnidirectional antennas. Both dipoles and quarter wavelength monopoles have an omnidirectional radiation pattern in free space. So this is the radiation pattern of collinear array. So the first one, radiation with two elements and pattern with three elements, and the next one is pattern with four elements. Here the antenna elements are stacked on one and upon the next one. So the next one is array of 2-point sources. The simplest array configuration is array of 2-point sources of same polarization and is separated by a finite distance. The concept of this array can also be extended to more number of elements, and finally an array of isotropic point sources can be formed. Point sources replace real antenna elements in order to determine the element spacing, lattice, aperture shape, and a number of elements that meet array performance requirement. So this is the arrangement of antenna array. So the radio waves radiated by each individual antenna combine and superpose, adding together so constructively the radio waves to enhance the power radiated in desired direction and cancelling the radiation in the other directions. Thank you.